Okay, so coming back to my data set, we just looked at these enrollment numbers. I want to do the same thing for the percentage of that school, or of the percentage of the students at the school who were fully immunized for the MMR vaccine. So I'm focused on this variable here, this value percent. I'm going to scooch over. And again, I need to get a sense of what range of values I have here. These are percentages, so I expect them between 0 and 100, but we might not have that full range. So I'll do equals min, highlight my data, equals max for my max value. And in this case, we do actually have percentages all the way from 0% to 100%. So the range here is obvious, but again, that range would be equals max number minus min number. Again, because this is a large data set, I'm going to shoot for something like 15 classes, maybe a little bit less. And if I take my range, so my range was 100 divided by 15, that tells me that each class should be about 6.6 wide. Now I'm not going to use 6.66666. I want to use a nice clean number. If I wanted to do more resolution, so more classes, I could do 5 here, right? If each class is width 5, I'm going to get 20 different classes, because 100 divided by 5 is 20. In this case, I'm actually just going to do 10. So I'll get fewer classes, a little bit less resolution, but the distribution won't be split up quite so much. Again, there's not typically one right answer here. All right, so my class width is 10. The lower class limit needs to start either at or just below the min. So I'm going to start my my first class with 0. And then I'm going to count up by tens. So rather than doing this manually, I'm going to do a formula. I'm going to take that previous class and add 10. Take that formula, drag it down. I'll come back and adjust how many classes I need later. And then the upper class limit, again, I'm looking at my next class is going to start at 10, which means this first class needs to end just before 10. Now, this data is not all whole numbers. So if I do 9 here, there's going to be a gap where something like 9.87 is going to fall in between here. So since this data has 2 decimal places in its rounding, I'm going to do 9.99 as my upper class limit. So there is still a gap here, but I shouldn't have any data values in between 9.99 and 10. Same thing here. I'm going to take that 9.99 number and add my class width of 10, and then drag this down. So I'm getting ranges 0 to 9.99%, 10 to 19.99%, etc. These percentages end at 100, so the last class I'll need is this one here. I'm going to delete the others. And this is a little bit unusual in this case in that really you can't have percentages above 100%, at least in this case. So this last range really is going to be just 100, not the range, but that's just kind of a feature of the labeling. Okay, now that I've determined my classes, I am going to do these counts. So again, here's the formula that we're working with. I'm going to use equals COUNTIFs. Select my data range. In that case, that's that immunized percentage from the data. The greater than or equal to ampersand lower bound. Select my data again. Less than or equal to ampersand upper bound. So equals COUNTIFs parentheses. I'm selecting the value percent column, comma, and then in quotation marks, I'm going to do greater than or equal to, and my quotations, ampersand, and then I'm going to select my first lower class limit, comma, select my data again, comma, and then in quotations, less than or equal to, ampersand, select my upper class limit. So this is counted up that within this percentage column, there were 17 values that fell in between 0 and 9.99 inclusive. I'm going to drag that formula down, and now I have the frequency counts for every single one of these classes.